Okay, this video has been made by PGL Surveys. I'm a civil engineering surveyor and I'm on a construction site, and we're trying to do monitoring of a wall that is serving currently as a retaining wall, and we want to spot any movement in it at an early stage while we pile in front of it. So first job is to determine where the instrument is, and we do that by siting some stations on site through a method called free station. So I've sited a station down here now, and the instrument now is turning to the next survey station to observe that. There'll be probably a tiny minor adjustment that I'll make, about 5mm or so. Okay, now the instrument has measured, so far has measured 3 survey stations. So what we're going to do, we're going to calculate how accurate the instrument is set up first of all, and it seems that things are good. There's no bad error coming back, so we look at what is called the residuals, which gives the indication of how accurate the instrument is, and they're found here. Okay, so I got residuals of 1mm in easting, 1mm in northern, and 0 in elevation. I've been consistently getting that, which means the survey stations haven't moved, and the triangulation is probably pretty good. So I store them instrument settings for where the instrument is. Now my next task is to start observing points along this wall. So what I'm going to do, I'm going to start off at 12, and I'm going to go on taking some readings from 12 onwards and see what we get. 12 is to the left of a grey patch of the wall, where we're going to start is to the left hand side of this picture. Okay, so to do that, I select a program, and there's a program on here called Stakeout. So point 12 is referenced in here by the words M12. So I've now typed M12 into the instrument, and it's going to search for it in the instrument memory, and now it's going to three-dimensionally stake out the point. So the instrument now is turned to where it should be. Okay, so I'm now going to get a result for M12. We're concerned with the northern and the level only, not so much the eastern. So the screen on my instrument is displaying 3mm plus in northern and 2mm. Okay, so it's 2mm cut, which means that is actually, the point is higher than we expected, which it wouldn't have gone up. So basically it does seem the point number 12 has come 3mm into the site. We're checking now point 13.
Yeah, good. Yeah,
Okay, point number 13 has moved 2mm into the site, and the level is nothing. It's the exact same level as before. As we can see, all the readings are 0 except the northern, which is a 2mm. So it's 2mm, it's come towards us, the retaining wall. So it's suggesting the retaining wall isn't a very strong retaining wall. It was here before we started, so we don't want to find our piles when we're driving these Larsen sheet piles are disturbing the current retaining wall. Okay, so point number 13 looks very good, and we're going to go on to point number 14. In 14, I search for it, bring it up in the memory, and you'll see the instrument turn on its own. Right, we're sighting point 13. Okay, and we're now going to take a reading to 14, and we've got 2mm in northern and nothing in the elevation of height. So basically that's suggesting that the point is come 2 millimeters into the site. So once again, the retaining wall is working as it should. Continue. Right, we're going to check point 15. And we're going to stake that. Okay, we have a lamppost up there on the site. If you look in the distance, it's between 15 and 16, and it's this section of wall we have the most concern about. We think there's a slight movement in it, so we're going to find out if there is. Okay, what we have here is 4 millimeters movement into the site and a 2 millimeter drop in level. So that's suggesting a movement. We'd be plus or minus 2 with this instrument really, so 4 mil is definitely showing some sort of movement. Going to point number 16, and we're going to stake point number 16 out. Right, I'm going to do the slight adjustment needed to figure out if there's any movement. And this is displaying the results for point 16. Right, we've got a 5 millimeters movement into the site, and we've also got a 5 millimeter drop in level. So if something has moved 5 millimeters into the site and it's dropped 5 mil in level, it's what is indicating a shear movement, because the when it's a shear movement, you get a downward reading. It's like 45 degrees. You got the downward movement is equivalent to the lateral movement. When the movement is not a shear movement, it's a peeling movement, we tend to get a lean into the site but not a drop in level. So there's going to also detect the types of movement we get on that. I don't know if I've explained that very well, but maybe I will the next reading. Okay, we're going along to point number 17. We're searching for it and we're staking it. The piling rig you see here is the big beast on site that's causing any disturbance to this retaining wall, and it's got a, on the end of it, it grabs the pile. It's the company's called Leica sheet piling, and they got a Movax unit on the side. It's a side grab unit. What it does, it grabs the pile at any point along the pile. It doesn't necessarily need to be at the top, and it can place that pile, twist the pile, do every sort of movement it's needed.